Dear students, in this video we will discuss about monotonic sequences. Here the first term is monotonic. So monotonicity is actually the pattern. Pattern may be increasing or decreasing or maybe constant. Fine. But in general we are discussing about the increasing or decreasing pattern. So here first definition is a sequence AN is said to be monotonically increasing if an plus 1 is greater than equals to an for all n belongs to n. That means the next term of the sequence is greater than equals to the previous term. So graphically you can understand this thing as this. Here is the domain 1, 2, somewhere is n, the next one is n plus 1. So if the value of the sequence at nth one is an here, then next value is either same, equal or greater. That's why this is. So that may be either this of the form or maybe of this kind, somewhere here or equal to. So either equal or greater than. So this is the meaning. Alternately, that is, if an is for all n greater than equals to m, the value will be this. That means if n is greater than equal to m, then obviously n is greater in comparison to, so value is also greater. If you are comparing their associative values, then they will also be greater than equals to, and this is valid for all n. So that's why for all n greater than equals to m, an is greater than equals to m. So this is an alternate definition. Here is an example. 1, first term is 1, next two terms are 2, 2, then 3, 4, 5, 6, 6. So this is a monotonically increasing sequence, and here the graphical depiction of this meaning. Similarly here, a sequence an is said to be monotonically decreasing if an plus 1 is less than equals to an for all n greater belongs to n. That means now the next value is lesser than the previous value. So graphically we can see here, this somewhere is n, then the n plus 1. So if some value is here, then the next value is less than that. That means we are having this kind of pattern actually. So value is, as n increases, value decreases. So n plus 1 is less than an, less than equal to an for all n belongs to n. Or alternately, in terms of somewhere, if suppose is here, because here n is greater than equals to n, so if m is here, n is here, that means n is greater than equals to m, then the value will be less in comparison to this. So that we are having, so that's why an is less than equals to am for all n greater than equals to m. This will be the alternate definition, and this is the graphical depiction here, and this is the example 10, 9, 8, 8, 7, 6, 5. So when you draw this, so you will see the decreasing pattern. So here important thing is that equality is there. That's why there are two terms 2, 2, 6, 6, equality. Similarly here we are having 8, 8. So equality holds. That's why equality, the same level. They are same level. They are of the same level. Fine. Now a sequence, in the third one, a sequence is said to be monotonic if it is either monotonically increasing, that means following this definition, or monotonically decreasing, that means this definition. So either monotonically increasing or decreasing, they will follow the, then they will say they are they can be said either monotonically increasing or decreasing. Fine. So if we are saying that a sequence is monotonic, then either it is following monotonically increasing pattern or decreasing pattern. Fine. Now if this, in this, these two definitions, if this equality is removed, that means strictly inequality is imposed, then the matrix, then the sequence is said to be strictly increasing or decreasing. So here are the associated definition. A sequence an is said to be monotonically increasing, strictly monotonically increasing if an plus 1 is strictly greater than an for all n. Alternately, when n is greater than equals to m, the associated values are strictly greater than that. And here is the an example. Example is sequence n. This is strictly increasing sequence. Similarly here, a sequence an is said to be strictly monotonically decreasing if an plus 1 is less than an for all n belongs to n. That means alternately, whenever n is greater than equals to m, the associative values will behave like this. An is less than am. And here is an example, 1 by n, the sequence. This is strictly decreasing sequence. So a sequence an is said to be strictly monotonic if it is either following this pattern, that means strictly monotonically increasing, or following this pattern, that means strictly monotonically decreasing. These are, so this we have already discussed this thing. Now we have taken two examples, they are not monotonic. For example, 0 1 0 1 0 1 0. So this is not monotonic. This sequence has no pattern. Pattern is only, values are only 0 1 0 1 0 1. They are not either increasing or decreasing. They are having no pattern. Similarly, in the next example, -2 -4 4, this is also not monotonic. So these are the counter examples. Now based on this, we have a theorem, and we will discuss this theorem in the next video. Thank you.